Okay, so next I'm going to work on some permute instructions. So this is 2F128, permute for D and W, and then the Q is down here, PSPD, and then ILPS. So we'll start with a VPERM 2F128. So we'll go to the assembly. We've got VPERMute 2F128. This only has a single form, which is YMM, YMM. Then we got YMM2 along with an immediate. So we'll just change this third one into a memory access, and that should be it for that one. So let's just check that. That's all okay. So next we'll move on to this VPERM D and W. So we've got VPERMW. This one has VEX only for the D version. The W version only has EVEX. So we'll start with W, which is EVEX only. So this has X, Z, and Y versions with op masks. And it goes RVM. Okay. So we'll do RVM. No immediates in these ones. So RVM, this one should be a memory access. And this can have op masks. Then we have a Y version and a Z version. So the VPERMD version has VEX and two EVEX ones. So if we just do D here, the VEX one is YMM, but it doesn't have any op masks. And then the EVEX versions are Y and Z, and those ones do have op masks. So we'll go down to Q. Q has VEX in the same way that the D one does, but this one is actually RMI and RVM. So RMI and RVM encodings. So we'll do VPERM Q. This one is RMI. RMI. Then we move up to EVEX with YMM. This one also has the I on the end, but this one supports op masks. And it supports broadcast. So this will be 1 to 4. So that's the Y version. Then we've got a Z version as well, where this one's broadcast will be 1 to 8. And then we've got the RVM versions of this. So let's just take this one. So we've got RVM. This one could be YMM2, and then this one can be a memory access. This one also supports broadcast. This will be 1 to 4. And we need ZMM here as well. Let's just make sure that that's all okay. Mismatch in number of broadcasting elements on line 33. Yeah, this needs to be 1 to 8. Okay, that all looks like it's fine. So then we've got PS. So this one is RVM only. So this is VPERMPS. We get Y for the Vex one, and then Y and Z. So YMM0, YMM1, and then YMM2. And the EVEX ones also support broadcast. So this one can be copied, and that one can be a memory access. Then here we've got op masks. Oh no, yeah, we do have op masks, but we also, for the memory access, have 1 to 8. And then we need a ZMM here, where this is 1 to 16. Okay. Then we've got VPERMPD, where this is doubling the element size, so the broadcast lanes have to halve. PD also has a couple of extra forms. So in this case, we've also got immediates. So VPERMPD, let's go and see over here. So we've got Vex is only RMI for this one, actually. Okay. Maybe I'll just do this one from scratch then. So we got RMI, which means this one can be a memory access. Then this one is also RMI, but this one is EVEX. And the memory access supports, let's say 1 to, this would be 1 to 4. Then we've got the Z version. Z version, what's the difference between these then? So we've got PERMPD, YMM with the, oh okay, it's just the different, this one's got the immediate and the other one doesn't. Okay, so these are the immediate ones. So this one is, that one supports a broadcast, then we need to copy these for ZMM. So because this broadcast vector width has changed, we can actually fit in 8 of them. Then we have these ones which don't have the immediate, so these ones are RVM. So we've got RVM, this would be YMM2. Yep, so now this one is the memory access. And we'll do the same thing for ZMM down here. But this one can now change to 8. Okay, that looks like it should be okay. We'll just check the listing for this. Okay, so we've got all of these. There's no duplicates in here, so it looks like I've done it properly. Yeah, okay, that all looks okay. And then finally, there's this VPERM ILPS. So ILPS has a couple of different operand encodings as well. None of these have immediates, they just go through RVM and RM encodings. So let's just go and create one here. So this is VPERM ILPS, and this one is RVM. Then we have, oh, we do actually have an immediate 8 version here, but it doesn't say it in the table down here. So this one is saying B assume then that this should be immediate 8. Because the other ones have immediate 8 here. So I'll just assume this is immediate 8. So this is actually RMI. Which means this one has to be immediate. So that's RMI. Then we've got the same thing for YMM. So that's the VEX versions. Then moving on to EVEX, we get the same stuff again. So this one is RVM. This one goes through XMM, YMM, ZMM. Then we get RMI again. So for all of these versions, we just copy. We'll just copy all of these. For EVEX, we'll put on an op mask. And the memory accesses support broadcast as well. So that one, this would be 1 to 4. This one would be 1 to 8. And this one will also be 1 to 8. Then we'll just take a copy of this one and change it to ZMM. And the broadcast goes to 1 to 16, I think. Mismatch number of broadcast elements on 81. Yeah, this should also be 16. Okay, let's go and look at the listing one more time. So this is ILPS. So for this one, it seems like there aren't any duplicate encodings in here, so I think I've got them all correct. Okay. Right, let's just generate some test notation for these. And regenerate the listing. Okay, now as usual, we'll just take all of the mnemonics. I think that's all of those. We'll just put them above blend D here. Deduplicate. So I'll just separate them this way. Okay, now let's just go and add them to the name table. And then add them to the form table. Okay, so go test should fail as usual. So VPERM2F128 only has a single form, so this is only going to match on Y-word for VEX. So we'll do family is VEX. Width is Y-word. The op-n is op-n RVMI. Op1, it can be a VEC. Op2 is also a VEC. Op3 is VEC or memory. And then op4 is an immediate 8. Prefix for this is 66. Map is 3A. 3A. And then opcode is 06. Okay, so now we're on to PERMW. So PERMW here is 3.8 with W set to 1 for all of these. These are only EVEX. W is 1. Opcode for this is 8D. The map is 3.8. Prefix is still 6.6. And then for these ones, we've always got RVM, where it's always vec, 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 or vec, vec, mem. So we've got RVM. This one should match for X word, Y word, or Z word. And then we'll also need to allow op masks with zeroing. So this is op mask with zeroing. Let's just see. This should be evex. And W doesn't support broadcast, so that's fine. Let me just check if I get rid of op mask. Yeah, okay, that's fine. So we'll put op mask back in here. D here is basically the same, but W is 0. We've also got a form for vex in this one. So this one is going to match YMM only. This one is Y word or Z word. They're all RVM still. This D version does not, the vex one does not support op mask or zeroing. And then we've got 3.6 for this opcode. Okay, and there's no, there should actually be broadcast for this one, so I need to go and add that to the tests actually. VPERMD. This one should include broadcasts. So this one is D, so this one should be 1 to 4. And we'll put the broadcast on that test. This one should also be 1 to 4. 1 to 4. Add broadcast. And then we'll add a broadcast to this one, where this one is 1 to 8. So I think that's all of them. Let's just regenerate that. Mismatch in number of broadcast elements. Oh, yeah, D is 32. Okay, so this should be 8. This should be 8, and this should be 16. Okay, that's fine. I've already got broadcast for the Q version here, so that's fine as well. So let's just retest this. So now it can't match the form for this one because I haven't allowed broadcasting. So let's just allow broadcast on this one. So now we're on to VPERMQ. So VPERMQ was a bit different. This one has RMI encoding. We've got vex and evex. So this is family vex. Op end for this is RMI. Op 1 is vec. Op 2 is vec or memory. And then op 3 is immediate 8. So for this one, we've got 663A. And then the opcode was 00. But this one has W is set to W1. Opcode. I've got a syntax error somewhere. Oh, we've got 2 op ends there. So PERMQ for Y, so this should be RMI. Yeah, this needs width. Width is Y word. Okay, so only word is on the VEX encoded, then eVEX gives Y and Z. This is also for RMI. So this is Y word and Z word. The difference between these is nothing, it's the same encoding, but I will need to allow op mask and zeroing, and I'll need to allow broadcast. So now we're on to the RVM encoding. So RVM here only has eVEX, which means that it should allow op mask and broadcasting anyway. This is also Y word and Z words. This is RVM now. So we've got RV. So get rid of mem and broadcast on here, change this one to VEC and move those over there. This one is now 3.6 with the W bit set. And okay, it looks like I've got another thing wrong here. This is 3.8 instead of 3A for the map. So this is 3.8. Okay, so now VPERMPS. This one only has RVM, and it's got VEX and eVEX. Let's just take this one because this one's already RVM. So we've got VEX and eVEX for this. So VEX only accepts YMM, so we'll change this to just Y word. VEX won't accept any op masks or broadcasting. And eVEX does accept broadcast and op masks, so I can leave those. This is 6.6 with 3.8, that's fine. Then we've got W0, and the op code is 1.6 for all of them. Don't need W for this, 1.6. I think that should all be okay. We've got Y word and Z word here. So now we're on to PERMPD. Let's copy this one, change this one to D. So for PD here, we've got we've got RVM versions, which are eVEX only in this case. So the VEX one is actually RMI. Okay, so VEX and eVEX all support op masks and broadcasts. This one is just the same, so 1.6 is the same here, but with W bits set. It's got the same map as well. Then we've got eVEX, which is Y word and Z word, but this is RMI encoding. So we've got RM, so this should be mem, and then I, this one should be immediate 8. And this one also supports broadcast on here. Then for VEX, we've got Y word only. This is also RMI. So we'll get rid of, so this is VEC or memory, and then I here for immediate 8. This one is 0, 1. With W1 is set on all of these. So W should be set to W1 here. So VPERMPD for RMI is a bit incorrect here. Oh, this should be 3A. Is it 3A for all of these? It's 3A for the immediate ones. So this one should also be 3A. Okay, so now we're on to ILPS. So ILPS has a couple of different operand encodings. So this one is RVM. Let's just take one of these. And this has vex and evex. So this one we'll do as vex first. We'll take off the op mask and the zeroing and the broadcast. These are all W0, so I can remove the W. This one is 0C for the opcode. And the map is 38. Prefix is 66. This one is RVM, so we've got vec, 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 mem. That's all okay. And then vex here is supporting x word and y word. Then we've also got RMI. So this one is RM, so this one should have memory, and this one should have immediate 8. Prefix 66, map is 3A for this one, and the opcode is 04. So now we're on to the EVEX ones. So EVEX has the same stuff. We got X, Y, and Z, but this time it also supports broadcast for all of them. So we'll just copy these ones, make these ones EVEX. They go up to Z word. This one supports op mask and zeroing, and then op 3. No wait, op. Okay, for this one the mem is broadcast, and then for this one op 2 is the mem with broadcast. So we've still got 0C and 04. Okay, that's all of the permute instructions.